Welcome. In this session, we are going to see the relationships among different operators. And we'll start by saying the relationship between the forward operator and the shift operator. So remember, E means is the notation to show shift operator, and this is the symbol or the sign for forward operator. So all the relationships will come from the definitions of these two operators. So we know that the forward operator of f of x is given by f of x plus h minus f of x. This by definition. And the shift operator of the function f of x is the same as f of x plus h. So I'll call this one equation 1, and I call this one equation 2. All these 1 and 2 are from definition. Now, so which means I can always replace equation 2 in equation 1 because this part has f of x plus h. So replace 2 in 1, i.e. 1 will be forward of f of x. So instead of writing f of x plus h, I write shift of f of x. And then minus f of x. Okay. Now, by doing this, the right-hand side has two terms, and those two terms have a common value, f of x. So we can write this one, f of x, forward of f of x equals to shift minus 1, and then we write f of x, factoring out the function f of x. Now, for this equality to make sense, then if we have the forward f of x and this bracket f of x, then this implies that the forward operator must be the same as 1 minus shift minus 1 for that equality to make sense. So therefore, the relationship between the forward operator and the shift operator is given by this, or we can say the shift operator is the same as forward operator and then plus 1, or 1 plus forward operator. So this is the relationship among these two operators, either this or this one here. And then let's prove some result here. So question, show that if you take the shift operator, you multiply by the forward operator, is equivalent by taking the forward operator multiplied by the shift operator. Now proof. So here, let f of x be the function Then shift forward of f of x will be given by shift of, definition of forward of f of x is f of x plus h minus f of x, which will give us the shift of f of x plus h minus the shift of f of x. And you see the shift operator takes you from the step where you are to the next step. So this will give us f of x plus h plus h minus f of x plus h. And you see this is just in line with the definition of the forward of f of x plus h. And you see f of x plus h from definition is the same as the shift of f of x. So remember, all this result is shift forward of f of x. So then it is directly from this that if you take the shift, you multiply by the forward, then for this equality to make sense, then it must be the same as the forward times the shift. So that's how we prove that result. And then another question, show that, prove that if you are given the forward of log of x, log of a function f of x is the same thing as defining log of 1 plus the forward of f of x divided by f of x. Now, to prove this, so proof, so let us define h to be the interval of spacing. So let h be the interval of differencing. Then f of x plus h is given by the shift of f of x, this by definition. And then we know that the shift operator from the previous result is given by 1 plus forward operator. And then this is f of x. So, which means that f of x plus h is the same thing as f of x, I just open these brackets, plus forward of f of x. So that's just by definition. So it implies that if I divide through by f of x, so dividing through by f of x, we get f of x plus h divided by f of x is given by 1 plus forward of f of x divided by f of x. Remember, forward of f of x over f of x cannot be crossed because this just one quantity different from f of x. And so applying, if I call this one equation 1, applying logarithms on both sides of 1, we get that log of f of x plus h divided by f of x is the same as log of 1 plus forward of f of x divided by f of x. At least we need to be smiling because now the right-hand side agrees with what we have in the equation. Now, using laws of logarithms, this implies that we have quotient of 2 values. So then laws of logarithms dictate that we'll have log of f of x plus h minus log of f of x will give us the right-hand side log of 1 plus forward of f of x divided by f of x. So then log of f of x plus h minus log of f of x defines the forward of f of x, which is the same as log of 1 plus forward of f of x divided by f of x. So this is the result that we were to prove. So that's how we work out that problem. And then next question. Evaluate second forward over shift applied to x cubed. So here we'll say let for solution h be the interval of spacing so then it implies that the second forward over the shift of this function x cubed will be, now write this one as right forward in terms of shift. So shift minus 1 squared divided by shift. And then this one we apply to x power 3. Now, this will give us shift squared minus 2 shift plus 1. You divide by the shift, and then you multiply by x power 3. Then dividing every term by shift, we'll get shift minus 2 plus actually shift raised power negative 1, and then x power 3. So then now we apply x power 3 to every part. So we'll have shift x power 3 minus 2 x power 3 plus shift raised power negative 1 x power 3. By definition, this will give us x plus h cubed minus 2x power 3, and then plus this negative, so it will be x minus h, and then power 3. And when you work out this, you'll get x power 3 minus 3 or plus 3x squared h plus 3xh squared plus h power 3 minus 2x power 3 plus x power 3 minus 3x x squared h plus 3xh squared minus h cubed. So here minus h cubed and h positive h cubed cancels out. This minus and this cancels out. And so we'll have x cubed plus x cubed will be 2x cubed plus 3xh squared minus 2x cubed, and then plus 3x h squared. So you see this one and this one cancels out. So we'll have 6x so 6x h squared. So that will be the sum of those two. That will be the simplification of that given problem. So that's how we manipulate the shift and backward, shift and forward. And also may be given another question, given that U0 is 1, U1 is 11, U2 is 21, U3 is 28, and U4 is 29. Find U0. So solution for this. So forward power 4 of U0. So just change this one to shift, which will be E minus 1 power 4 U0, which will be given by, if you use binomial expansion, you have E power 4 and then minus 4 E power 3 plus 6 E power 2 minus 4 E, and then plus 1 plus 1 and this one we apply to U naught. And this will give us e raised power 4 U naught minus 4 e raised power 3 U naught plus 6 e raised power 2 U naught minus 4 e raised power 1 U naught plus U naught. And you see, we know that, note that e raised power k or e raised power n e raised power n of f of x is given by f of x plus n h, which is the same thing as saying e raised power n f sub k is given by f sub k plus n. So this result is going to help us reduce these terms. So when you say e power 4 u power z u naught is the same as u naught plus 4, which is the same as u 4. E power 3 u naught is the same as u naught plus 3, which is u 3. So this will give us u4 minus 4 u3 plus 6 u2 minus, this just be u1 minus 4 u1 and then plus u naught. So when you replace in the values, you will get 29 minus 4 times u3 was given by 28 plus 6 u2 was given by 21 minus 4 u1 was given by 11 and then u naught was given by 1. So when you work out, you should get 29 minus 112 plus 126 minus 44 plus 1, and the answer is 0. So next time we'll give more examples on how to apply the relationship between the shift operator and the forward difference operator. Thank you.